Right, loci using complex numbers. Okay, let's do this. So the first one is actually not too bad. We're told that we've got the argument of a complex number is pi over 4. By the way, if you just had arg z is equal to pi over 4, then we'd be saying that it's any complex number like this, but except it can't be 0, 0. When we've got a plus 2 and a minus I, we're just essentially doing a translation. It's actually going to be minus 2 along the real axis and plus 1 in the complex. So that is going to where, actually, I'm going to put a little circle there. That's where it's going to start. Because it's pi over 4, that is 45 degrees. So it's going to go along 1 and up 1, along 1 and up 1. It's actually going to look like this. I can see it's going to go through 3, in fact. In fact, it's going to become the equation y equals x plus 3. That will describe that straight line. So I've got that bit sorted. Now for the other one, more complicated. So we've got 2/3 pi. Remember, pi over 2 is 90 degrees. So 2/3 is going to be beyond 90 degrees. It's going to be going back that way. For example, if it was just arg z equals 2/3 pi. But it's not. We've got, again, some translations going on. So it's going to be 2 plus root 3. Maybe it's going to be around like here and then up 2. So I reckon here. And then I'll draw a line going up like that. Now, it's not quite as easy to just write the equation down for the second one. The best thing to do, I think, is to return to kind of the general idea, in fact. So we have that the argument, or tan of the argument, of z is going to equal, well, this is my y and this is my x, it's going to equal y over x. So I can use that here. I'm going to get tan. It still works when you go beyond 90. So that's why it's good to just do it for this one here, and it does extend. So tan of 2/3 pi is going to equal my y component, which in this case is actually y minus 2, because I've got my y here, but then I've got an additional minus 2i, yi coming from the z, I should say. And then x minus 2 minus root 3. Okay, it's a little bit more awkward, but I've got myself an equation of a straight line. So we need to be working in radians here. Tan of 2/3 pi is minus root 3. In theory, you could do that without a calculator. So y minus 2 is going to equal minus root 3 times x minus 2 minus root 3, which is minus root 3x plus 2 root 3 plus 3. And hence y is equal to minus root 3x plus 2 root 3 plus 5. So I've got these two, I'm just going to underline them. I've got these two equations, and let's just look at the loci now. So we want to find out where they're both, a point on both of the lines. It's got to be here where they intersect. There's going to be one point in our intersection of C1 and C2. So what we can do is solve it, set x. So find point of intersection. X plus 3 equals minus root 3x plus 2 root 3 plus 5. I can add root 3x on and then factorize out the x. So 1 plus root 3x is going to equal 2 root 3 plus 2, which in fact is 2 lots of root 3 plus 1. And if I divide through by that, this root 3 plus 1, we simply get x equals 2. And from that, y is going to equal 5. And that's my coordinate. Okay, I didn't do a bad job of my sketch, actually. So finally, C1 intersected with C2 is going to be simply the set 2 plus 5i. Turn it back into a complex number. That's what we're actually interested in. I can't just leave it as a coordinate, but it's just this single number.